Today's class is focused on the identification of four basic types of reaction that are combination reaction, decomposition reaction, displacement reaction and acid-base reaction. And for this I have taken some reaction and just the reactant side is only taken. Looking at this, we are going to complete this reaction word equation first, and then we'll write formula equation, and then we'll write balanced chemical equation, and we will identify which type of reaction it is, either combination or decomposition or displacement or acid-base reaction. Let's start. But before writing these chemical reactions, we have to remember that some elements are diatomic. What are they? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine and iodine. What it means? Whenever they become free, then we'll write S2N2O2F2 for them. Not S for hydrogen, not N for oxygen, N2. Whenever they become free, they are always in diatomic form. That's why we'll write them as diatomic form in the chemical reaction. Let's start. Okay, let's see. Lead oxide. Lead means Pb. Okay, better. Lead means Pb. Oxide means O. Lead valency 2. Oxygen valency 2 equal valency, no exchange. And this is nitric acid, HNO3. We have to remember the formula of nitric acid directly. That's why we don't have to transfer the valency. Now this is metallic oxide. Metallic oxides are bases, and this is directly acid. This is acid-base reaction, and we know that when an acid reacts with base, then the product will be salt and water. And how salt forms? The hydrogen of metallic part is displaced by the hydrogen of the acid is displaced by the metallic part of the base. That's why lead takes the place of hydrogen, and we'll have PbNO3, Pb valency 2, nitrate valency 1 we don't have to transfer, and valency of lead has to be transferred. But when we give valency to a radical, then we'll put that radical into bracket, and then another product is water, H2O. Now what are the product? This is lead nitrate, LEAD, lead NITRATE, nitrate plus water, lead nitrate plus water. Now we are going to balance this equation. Look at this oxygen 1. I am not counting this oxygen because here we have nitrate, here also nitrate. We will count nitrate on both the sides, and oxygen is 1, oxygen 1, okay, hydrogen 2, hydrogen 1. That's why if we take here 2, then hydrogen is balanced. Now nitrate is 2, nitrate 2, okay, lead 1 equal. Thus just now we balance the equation. And what type of reaction is this? This is acid-base reaction. Okay. Now let's go to another one. Aluminium when reacts with sulfuric acid, then what happens? It will be better to have first formula equation, aluminium Al plus sulfuric acid H2SO4. When a metal reacts with acid, if reaction occurs, then metal displaces hydrogen from acid, then we'll have AlSO4, aluminium valency 3, sulfate valency 2. That's why we have to transfer 2 to aluminium and 3 of aluminium to sulfate, Al2SO4 whole 3, and hydrogen is displaced, and when it becomes free, it is diatomic, as I told you just now, and this is S2. I wrote this formula equation. Now I want to complete this word equation. What is the name of this? Aluminium sulfate. Aluminium sulfate, and another product is hydrogen. And reaction is not balanced till now. Hydrogen 2 seems to be okay. Now sulfate is 3. Now sulfate here, if we take here 3, it is balanced, but hydrogen is again imbalanced. 3 2s are 6. We have 2 here. That's why it's better to have 3 here. Hydrogen and sulfate are balanced. Aluminium 2, aluminium 2. This way, this is balanced chemical equation. But what type of equation is this? Metal reacts with acid. It means this, it displaces hydrogen. Displacement reaction. This is single displacement reaction. Displacement reaction. I'm writing shortly. Okay, now let's go to another one. Potassium when reacts with chlorine, what happens? Potassium, its symbol is K. Chlorine, its symbol is Cl, but it is diatomic. There I have written there. And when they react, then certainly they combine with each other. No way two elements are taking part in the chemical reaction. They combine with each other to form potassium chloride. Now, valency of potassium is 1, chlorine is 1, equal valency, no exchange. Now, I want to balance this. Chlorine 1, chlorine 2, if we take here 2, this is, chlorine is balanced. Potassium 2, if we take here 2, okay. Now, what is the product? This is potassium chloride. Potassium chloride. Now, what type of reaction is this? Two elements combine to form single compound. This is combination reaction. This is combination reaction. Very simple. Okay, now let's go to fourth one. Zinc carbonate. If only one compound undergoes reaction, then certainly maybe it is heated and it decomposes. Normally zinc carbonate, when heated, it decomposes. That's why we have to write for first formula equation ZnCO3. Now zinc valency 2, carbonate valency 2, equal valency, no exchange. When zinc carbonate decomposes, it forms zinc oxide and carbon dioxide. Like calcium carbonate, when decomposes, calcium oxide and carbon dioxide. When a metallic carbonate decomposes, it forms metal oxide and carbon dioxide. That's why zinc oxide, ZnO plus. Zinc valency 2, oxygen valency 2, no exchange. Carbon dioxide, we know its formula CO2, directly I am writing CO2. Now what are the products? This is zinc oxide, and another one is carbon dioxide. Now, whether it is balanced or not, once let's see. Oxygen 2 and 1, 3, 3, okay. Carbon 1, okay. Zinc 1, okay. Now, what kind of reaction is this? This is decomposition reaction. One compound is decomposed. That's why I am writing here decomposition. Shortly, decomposition reaction. Okay. Let's go to another one. Magnesium chloride reacts with washing soda. Magnesium chloride when reacts with washing soda, what happens? Magnesium chloride. Magnesium is Mg. Chloride means chlorine is combined, Cl. And magnesium valency 2, chlorine 1. That's why MgCl2 1 we don't have to transfer, but 2 is transferred plus. Washing soda, molecular formula Na2CO3. Directly, if we remember, this is the commercial name of sodium carbonate. Sodium carbonate, if we write for sodium carbonate and exchange valency, that's also okay. Now what happens to the product? What product we'll get? This metallic part combined with non-metallic part. Here also metal and non-metal are combined with each other. Metallic part, non-metallic, metallic part, non-metallic. In this kind of reaction, in this type of reaction, what happens? Metallic part of first compound displaces the metallic part of second compound and vice versa. The second also displaces the first. This way, MgCO3. Magnesium MgCO3. Magnesium valency 2, carbonate valency 2, equal valency, no exchange. In the same way, sodium chloride NaCl. Now sodium valency 1, chlorine valency 1, equal valency, no exchange. Now we can write the name also. Magnesium carbonate. Magnesium carbonate. This is magnesium carbonate plus sodium chloride. Magnesium carbonate plus sodium chloride. This is the product. Now I have to balance equation. Chlorine 1, chlorine 1, 2. That's why if we take here 2, chlorine is balanced. Now it's turn of sodium. Sodium 2, sodium 2. Okay. Carbonate 1, carbonate 1, magnesium 1, magnesium. Okay. Now this is double displacement reaction. And that's why we can write just displacement reaction. Displacement reaction. Okay. Sulfuric acid plus sodium hydroxide. Sulfuric acid is formula is H2SO4 plus sodium hydroxide NaOH. Sodium valency 1 is directly remembered. The sodium 1, hydroxide 1 equal valency, no exchange. This is acid base reaction. How do we know this? Because this is metallic hydroxide. This is just written here, acid. This is base. Metallic hydroxide is base. Okay. Now, what is the product? Salt and water. How salt forms? Sodium takes the place of hydrogen. That's why NaSO4. Sodium valency 1, sulfate valency 2. That's why Na2SO4 plus another product is what? Water. Now I want to write the name of these compounds, products. What are they? Sodium sulfate, sodium sulfate plus water. Now let's balance the equation. Oxygen 1, I am not counting sulfate, oxygen of sulfate, because sulfate is present on both sides. That's why we will count sulfate. Oxygen 1, okay. Hydrogen 2, hydrogen 1 and 2, 3. In left hand side, we have 3, odd number. That's why let's convert odd number into even. If we take here 2, oxygen, hydrogen 2 plus 2, 4. That's why we have to write here 2. It's balanced, but oxygen, what about oxygen? Oxygen 2, oxygen 2. Okay. Sulfate 1, sulfate 1. Now, sodium 2, sodium 2. This is balanced equation. And as I told you, this is acid-base reaction. Acid-base reaction. Now, I am doing last reaction. The last reaction is what? Nitric acid and magnesium hydroxide. Let's write it with blue ink and from the beginning. Okay. Nitric acid, if you remember, HNO3. This is directly, we have to remember this. Magnesium hydroxide, magnesium Mg, hydroxide is OH. Magnesium valency to hydroxide 1. 1 we don't have to transfer, that's why magnesium 2 is given to hydroxide. If we have to transfer valency to a radical, then we have to put that radical in bracket. That's why MgOH2. Now, what is this? This is acid. This is metallic hydroxide, means this is base. This is acid-base reaction, and the product is salt and water. How salt produces? This magnesium displaces hydrogen. That's why MgNO3. Magnesium valency is 2. Nitrate 1. That's why valency of magnesium should be transferred to nitrate, to MgNO3 whole 2. And another product is acid-base reaction. That's why second product is water. Now let's write this product in words. Magnesium nitrate. Magnesium nitrate, and another product is what? Water. Now we have to balance also. Balancing is not finished. Oxygen 1, I am not counting nitrate because I am not counting this oxygen, because nitrate will count. Oxygen 1, oxygen 2. That's why it's better to have here oxygen 2. Now hydrogen 2 to the 4, here 2 and 1, 3. Here we have odd number. That's why I want to make it even. 2 plus 2, 4, and 2 to the 4. Okay. Nitrate 2, nitrate 2. Okay. Magnesium 1, magnesium 1. Okay. And what type of reaction is this? This acid metallic hydroxide base. That's why we identified it as acid base reaction. Okay, these are some examples How to identify this combination, decomposition, displacement and acid-base reaction. Today's class was focused on that. This much for today.